Welcome to my assignment 3. My name is Jonathan Seltzer. So we're basically going to run part A, which is basically just importing our packages and libraries. As you can see, it's being imported. Last one, we are doing line detection here. So basically for question 1, we're using lines. So for the first one, we're basically creating a kernel to detect 45-degree lines using above image. So basically, we are calling the same thing as above, but we're just changing the array or slash um, the kernels for the image, which would be at 45 degrees. So you can see below, this is a 45-degree kernel. As you see, we just reprint it. The images are completely different because it's detecting 45 degrees for the image. For question B, we're doing the exact same thing, but we got to switch the numbers around for a 135-degree line instead, which would detect it for the image, as you can see below. And you can see the images are completely different. For question 2, we're doing edge detection. So we have the following kernels provided to us, and we basically had to plot the outputs, as you can see below. So the first one is basically not really focused on any of the center pixels, it's more focused on the outskirts or the very corners of the array. As you can see the image below, it's not really light in, it's mostly dark because it's focused more on the outer part of the array. For B, we got further in depth and we start focusing on the center pixel, and we basically are doing a cross, so it's like a little plus sign going around the image. As you can see, it starts picking it up in color because it's more centered around the pixel, but it's not too focused, so it's like not too bright. It's more like in between, so it's still registering the image, but not fully. For C, we're going further into depth, which basically is doing the same thing as 2, but we're doing it as 8 instead, which is focusing a lot more on the pixel compared to the one on the question 2. We're also doing negative 1s on the outskirts of the 8, so as you can see, it's getting better on the lines, and it's also getting more dimmer on the sides, as you can see. Part B, we're importing libraries, as you can see, and we're preparing the data sets also. You can see, not going further into it, but the biggest one would be here, would be creating the model, which we used a lot. Also, model compile would be used a lot, and the summary of the model. As we go down, it's also training the network. So this part I would not run because this will take a while. It takes super long to run this. The first thing here is our graph, which is showing us our validation and training accuracy. And based off the graph right here, we basically have our validation starting not slightly, but like later than our training, where our training starting at 0.4, and it's just accelerating. And our validation's increasing, but as soon as it hits a certain point, it starts like overfitting or like easing down, so it's not really validating any information accurately now. It's just staying at whatever it's at, so it'd be like a 0.65 based off the graph. But it could increase, but it's not really a good thing. We would want it to increase. For question 3 now, did the network present signs of overfitting? Which I did say. So I said 20 based off the graph. But no, it starts hitting around 20, 25. If you look at the graph around here, as you can see, at 20, just the start. So we're like, oh, it can increase or decrease. It does not. It just starts staying exactly like this until 30, which is a sign of overfitting. Number 4, write how many layers in this model has and identify their types. So earlier we called it. We have 5 types in our model, and each is here. We got 2 denses. We have 1 flatten, 1 max pooling, and 1 cog2d. And then for question 5, we're briefly explaining what each one does. of those layers. So basically, the convolutional layer extracts features from the images for the operations for the convolutions, like example above. For the pooling, or just downsampling or compressing the maps to reduce dimensions, so it's making it easier to read for it and still keeping important information. Line layer is just making it simpler for our data set to be read, since it'll be a one-dimensional rather than a multi-dimensional, because multi-dimensional has if it's a 3D image, it has to measure 3 different ways compared to one dimension, which is just 2, or you could say 1. For the dense layer, it's learning complex patterns between features, but there's not many complex features in the data we provided. It's like a little bit, it's not too complex, so it's not really too crazy, but it's based off mind like image or view of it, but there could be complex because it's a car. Output dense layer. This is the second dense layer. It's just producing the final predictions of the data and just giving us what we would like to see or we compare to. Question 6. We're adding a layer to our model and running it again. So I'm not touching it, but I'm just recalling the model here and just adding more to it. So I'm adding 2 convodids. And then after I'm doing a max pool also, and a flat and a dense. So as you can see, as we go below, we're also calling it the model again to run it to show. So you can see this is basically running it again. So because there's like slight difference because I changed, okay, I added more. So as you can see, there was more added, but as soon as we add more and start accelerating more up there, the training accuracy actually starts wavering a bit. But the validation also starts just like not increasing or decreasing, just at a set pace. But we also have our validation starting later and our training starting later, which is not really good. Comparing the 2 results, since I added more data to our data set, it starts wavering at at the 100, like not 100%, but the highest accuracy, and the validation starts easing now, which is not really a good thing. But I left some notes here, but yeah, I'll say what I just like basically said. The training accuracy is like basically everything's just slightly different compared to each other. Like the beginning is different, the end is different, the peak is different, the the validation's just like more ease. It's not really increasing or decreasing, but it's not really a good thing. As you can see, I state the stability of the model in a second might be more robust and less to overfit, but as you can see, for 8, we're adding a dropout layer to the model and comparing it to the result previous one. So a video is provided for us for dropouts. I'm not going to run this because it'll take a while to run. As you can see, this is the dropout. So for the dropout and how it works, so it prevents overfitting, and then depending on the dropout number of neurons will not work. While some for that layer, some will look at patterns. So basically, it's like validating in like, how do I say it? Like patterns roughly. So it's like choosing example like if there's 3, it's choosing like 1 and 3 or like 1 and 2 once in a while. It's just repeating itself in different patterns. It's basically uh, validate and train the data. As you can see in our results, we have a validation at a perfect line here, but as you can see, the training just starts going up and down, which is not really a good thing, but it's also preventing overfitting, which is somewhat okay, but yeah. For question 10, I didn't do this. I did not have enough time for this. And thank you for your time.